So other web application threads. After looking at OWAS top 10 threads, let's look at other threads. Directory traversal. As you can see, there are different ways. There are different methods of directory traversal. Uh, Unvalidated redirect, unvalidated forward. So, in unvalidated redirect scenario, a user receives a phishing email from an attacker, luring the user into clicking the link. The link appears to be legitimate because it contains the same name of a legitimate website such as www.certifiedhacker.com at the beginning of the URL. However, the later part of the link contains a malicious URL to which it redirects the victim. When the user clicks the link, it redirects to evilserver.com website, and the server that hosts the website might perform illegal activities such as harvesting the user credentials, deploying malware, and so on. Okay, sorry, this unvalidated redirect is not part of directory traversal, but it is a completely different type of web application threat. So after unvalidated redirect, we will see unvalidated forward. Unvalidated forwarding allows attackers to access sensitive pages that are generally restricted from viewing. During unvalidated forwarding, attackers request a page from a server with forward, that is by entering a link with an embedded forward query. As you can see here, there is a query called FWD added to the URL at the end. So if you see, the value of admin.jsp is assigned to FWD. So when this URL reaches the server hosting the certified hacker website, the server without proper validation redirects the attacker to sensitive admin page where she can access purchase records, registered users, and so on. So directory traversal attack is simple. You can add a directory traversal commands to the URL as shown here, and then look at the look at the folders which are otherwise hidden to the web application users or clients. So next is watering hole attack. It is a type of unvalidated redirect attack whereby the attacker first identifies the most visited website of the target, determines the vulnerabilities in the website, injects malicious code into the vulnerable web application, and then waits for the victim to browse the website. Once the victim tries to access the website, the malicious code executes to access the infected application. This attack is called watering hole as the attacker waits for the victim to fall into trap, similar to a lion waiting for its prey to arrive at a watering hole to drink water. So the next attack is cross-site request forgery (CSRF). CSRF attacks exploit web page vulnerabilities that allow an attacker to force an unsuspecting user's browser to send malicious requests they did not intend. The victim holds an active session with a trusted site and simultaneously visits a malicious site, which injects an HTTP request for the trusted site into the victim's user session, compromising its integrity. Cookie session poisoning is the next attack. By changing the information inside a cookie, attacker bypasses the authentication process. Once they gain control over a network, they can modify its content, use the system for a malicious attack, or steal information from user system. As you can um, see in this diagram, here the first step is user browsers a web page. Second step, web server replies with a requested page and sets a cookie on the user's browser. Here he is trying to buy some stuff which is priced at 11,568. So after the web server replies with the requested page, and after it sets the cookie on the user's browser, the third step is attackers steals cookie, maybe by sniffing or phishing attack. So and after stealing the cookie, the attacker in the fourth step, attacker orders product using modified cookie. So the fifth step, product is delivered to attacker's address. So here in the fourth step, the attacker has modified the price from 11,568 to 100, as you can see in the diagram. Web service attacks. An attacker can get into target web application by exploiting an application integrated with vulnerable web services. An attacker injects a malicious script into a web service and then disclose and modify application data. Cookie snooping. Attackers use cookie snooping on victim system to analyze the user's surfing habits and sell that information to other attackers or to launch various attacks on the victim's web applications. Hidden field manipulation. A hidden field lets web developers include data that cannot be seen or modified by users when a form is submitted. Attackers attempt to compromise e-commerce websites mostly perform such attacks. They manipulate hidden fields and change the data stored in them. Several online stores face such problems every day. Attackers can alter prices and conclude transactions, designating prices of their choice. Next is authentication hijacking. For authenticating a user, every web application employs a user identification method such as an ID and a password. However, once attacker compromises the system, they can perform various malicious activities such as session hijacking and user impersonation and hijack the session. So obfuscation application. Attackers are usually careful to hide their attacks and avoid detection. Network and host-based intrusion detection systems constantly look for signs of well-known attacks, driving attackers to seek different ways to remain undetected. The most common method of attack obfuscation involves encoding portions of the attack with Unicode, UTF-8, base64, or URL encoding. Unicode is a method of representing letters, numbers, and special characters to properly display them, regardless of application or underlying platform. Next is broken session management. Broken session management is a type of authentication vulnerability that emerges when session persistence is not implemented correctly. If session IDs are exposed in the URL, then web applications are vulnerable to session fixation attacks. Furthermore, if the session timeout is longer and the session IDs are not changed after every login, attackers may hijack the session and take control of the session with the same privileges as the victim. Next attack, broken account management. Vulnerable account management functions, including account update, forgotten or lost password recovery, reset password, and other similar functions, might weaken valid authentication schemes. Denial of services. A DOS attack is an attack on the availability of a service which reduces, restricts, or prevents access to system resources by its legitimate users. For instance, a website related to a banking or email service may not be able to function for a few hours or even days, resulting in the loss of time and money. Buffer overflow. CAPTCHA is a challenge response type of test implemented by web applications to check whether the response is generated by a computer. Although CAPTCHAs are designed to be unbreakable, they are prone to various types of attacks. Platform exploits. Users can build various web applications using different platforms such as BEA, WebLogic, and Cold Fusion. Each platform has various vulnerabilities and exploits associated with it. Network access attacks. Network access attacks can majorly affect web applications, including a basic level of service. They can also allow level of access that standard HTTP application methods cannot grant. DMZ protocol attacks. The demilitarized zone (DMZ) is a semi-trusted network zone that separates the untrusted internet from the company's trusted internal network. An attacker who can compromise a system that allows other DMZ protocols has access to other DMZs and internal systems. This level of access can lead to compromise of the web application and data, defacement of websites, access to internal systems including databases, backups, and source code. Web-based timing attacks. Again, it is divided into two categories: direct timing and cross-site timing attack. Direct timing attacks are carried out by measuring the approximate time taken by the server to process a post request, through which attackers can deduce the existence of a username. Similarly, attackers can perform character by character password examination and exploit the timing information to determine the position where the password comparison failed. Then the attackers use this data to determine the target user's password. Cross-site timing attack. Cross-site timing attack is another type of timing attack in which attackers send crafted request packets to the website using JavaScript. Unlike direct timing attack, whether the attacker himself passes the request to a website where unlike direct timing attack where the attacker himself passes the request to a website, the attacker then analyzes the time consumed by the user to download the requested file. So here the differences is the attacker is making the user to send the request packets to the website. For instance, consider a website xyz.com that contains two separate groups such as the prompt and the anonymous place, and only the group members have access to the data fed into these groups. If any other person tries to access the group, an error message is generated. Now, when a user accesses an unknown website that contains malicious JavaScript injected by the attacker can find out which group the user belongs to and thus violate his her privacy. So, function get measurement URL comma callback. He is using a function called add event listener, and then callback conclude minus begin. So you can see the code. Try to understand this. Similarly, there is something called as browser-based timing attacks, video parsing attack, cache storage timing attacks, clickjacking attack. Clickjacking attack: the attacker loads the target website inside a low opacity iframe. What is inline frame? An inline frame is a HTML element that loads another HTML page within the document. So there is a detailed description given for the clickjacking, hijacking. Can pause the video and read the description. The next attack is marionette attack. Note, marionette is a puppet controlled from above using wires or strings. This is a browser-based attack in which a malicious code is executed. This infection persists even after closing the browser or browsing away from the web page which caused this infection. In this, the attacker registers and activates a service worker API through a website controlled by the attacker. So when the victim browses that website, service worker automatically activates and can run persistently in the background. It can be used to create a botnet and launch other malicious attacks such as cryptojacking, DDoS, click fraud, and distributed password cracking. So in the next video, we will see web application hacking methodologies.